Welcome everyone to this year's Cosmic Carnival and also to a talk about the Artemis mission, which will be the one that's going to return people to the moon in the next few years. But before I start talking about Artemis, let me tell you a little bit about the Cosmic Carnival. It's an annual event organized by the Albuquerque Astronomical Society in the city of Albuquerque Open Space Visitors Center. The Cosmic Carnival presents exhibitors with astronomy and science-related topics for the enjoyment of all of you that join. Normally, the event is held in person at the Open Space Visitors Center, but circumstances in 2020 and this year have compelled us to have the event held virtually through the Open Space Visitors Center website, which is where some of you may be watching from. Thanks for being part of the 2021 Virtual Cosmic Carnival. We hope you enjoy it and the exhibits and live presentations. If you've checked out the website already, you know there's instructions at the top, and basically it's a page with different recordings for different topics related to space science that you can watch. And I believe this webinar is actually going to be posted, the recording of this webinar is actually going to be posted later when we're done with it. So if you missed part of it, feel free to check back. And there's actually going to be another webinar presented by Aziz Gonzalez from the Santa Fe Children's Museum that's happening later today at 5 o'clock. He's going to give you a tour of the night, a virtual tour of the night sky. So I hope you all can join in for that as well. All right, so let's go ahead and get started talking about Artemis. I'm going to share my screen with my presentation. There we go. Okay, so this talk is going to be about the Artemis program, which has plans to send people to the moon and also to Mars later on, which I'll talk a little bit more about towards the end. I'm Jim Greenhouse. I'm the Space Science Director at the New Mexico Museum of Natural History and Science. And I do not work for NASA, and I have nothing to do with the Artemis program myself. But I'm part of a group of informal science educators across the country that NASA has allowed access to materials about the Artemis program. So all the slides that you're going to see were actually produced by NASA. And the information that I'm going to give you is they've made available to these folks that are doing talks like the one I'm doing today. And so it's hopefully some of the latest information about the Artemis program. But in just a little while, I'll give you the website for the Artemis program, and you can keep up to date with what's happening through the website. So before I start talking about Artemis, I'm actually going to talk just a little bit about the Apollo program, which was the previous program that took people to the moon. We actually, back in 2019, celebrated the 50th anniversary of Apollo. And there were a lot of celebrations held all over the place. We had a few programs that we did here at the Natural History Museum in Albuquerque. But there were a lot of videos released and a lot of celebrations since this was a major achievement in space science. It all started back in 1962 when this president, John F. Kennedy, actually presented a talk where he challenged the United States to land a man on the moon by the end of the decade. And they just barely made that deadline. They actually launched a person to the moon that actually landed on the moon and walked on the moon in 1969. So just barely before the end of the decade. And you see the logo for the Apollo program there on the right side of your screen. So this is the launch vehicle that took the Apollo astronauts to the moon, and also some test flights before that. So Apollos 4 through 10 were actually test flights that went up into space and either orbited around the Earth or went into orbit around the moon, but none of them actually landed on the moon. The first mission that actually landed on the moon was towards the center of your screen there. That was Apollo 11. And then all the Apollo missions after that, except for Apollo 13, if you've seen the movie Apollo 13, you know they had some problems and were not able to actually land on the moon during Apollo 13. But it was still an historic mission because of the ways in which they were able to get the astronauts out of trouble and return them safely to the Earth. There was one additional Saturn V launch for Skylab 1, which was actually the first space station. So the International Space Station is actually not the first space station. Skylab 1 was. It was basically a very big open, well, some people called it a tin can, but it was basically a big open design for a space station. It had lots of instruments around the edges, and astronauts were able to go for maybe a few days or a few weeks at a time. They weren't able to stay there for very long. So the International Space Station that we have up there now is a big leap forward, since people are able to stay there for months. And this is a basic drawing of, notice the top of the Saturn V rockets. This was just a very small part of the rocket was actually used to take the people to the moon. So at the top there, you see the command module, and you see the astronauts in their spacesuits in there. On top of that is the launch escape system. So that little rocket was used just in case something happened during one of the Saturn V launches. The command module could detach, and the launch escape system would carry the astronauts away to safety. Fortunately, they never actually had to use that system during any of the Saturn V launches. They all went fine. That launch escape, the rockets for the launch escape system were actually tested at White Sands Missile Range, though, here in New Mexico. The service module is below that, which is basically the mechanics for the command module, and also the rocket that actually lifted people from low Earth orbit and delivered them to the moon. Underneath that, and you see the engine mark there, and underneath that is the lunar module, which is the spacecraft that actually two of the three people from the command module would transfer over to the lunar module once they reach lunar orbit, and then the lunar module is the spacecraft that actually touched down on the moon and let people walk on the moon. This is the inside of the Apollo 11 command module. If you would like a more detailed look, you can actually go to that link at the bottom of the screen there and download an app called Planetary AR. And there is a target that you print out for the moon. And when you load that app up and hold your tablet or your phone up to that target, you'll actually have a choice to do a virtual tour of the Apollo 11 command module. So you can point your phone in different directions, or your electronic device, your tablet, whatever you have, in different directions, and you can actually look around inside the command module and see all the buttons and switches and knobs and everything that the astronauts had to remember what they did during their flight. I hope you can see my cursor here. Right there in the middle of their console, that was their computer that they used. And it was a very, very simple computer. In fact, if you have a smartwatch, your smartwatch is probably way, way smarter than the computer that they had on the Apollo command modules. Of course, this was back in the 1960s, so they were just beginning to, design anything that was like a computer. And the whole thing was just sort of a marvel of technology for the time, that they were able to carry people all the way to the moon with the technology that they had at the time. And there's a picture of the lunar lander that actually sitting on the surface of the moon. Over on the left side of your picture there, you see one of the astronauts and the American flag. Over on the right side, you see the moon buggy, which was a little vehicle that they used to actually drive around on the surface of the moon. So they were able to go a little bit farther away from the landing site and do a little more exploration during that, using that vehicle. This was from Apollo 15, I believe. And then when they, left the moon and got back in the command module, they were actually landed back on the Earth by splashing down in the ocean. So on the bottom side of the command module, there was a heat shield. So the command module would descend through the upper atmosphere. The heat shield would protect them. Then at a certain altitude, parachutes would deploy that would slow it down, and then they landed in the water, since it's a lot safer and softer than landing on the ground. And these are, so back in 2019, during the 50th anniversary of Apollo, they had, one of the many celebrations that they had was for the Apollo astronauts that were still alive at the time. So you see that there's Buzz Aldrin. He really stands out with his suit and his socks and everything on. but you can see that there are some astronauts that actually walked on the moon, and those are in the sort of the bright yellow color. The ones that actually did not walk on the moon because they were either the command module commanders, or they see Fred Hayes there was on Apollo 13. They actually went to the moon but did not set foot on the surface. And unfortunately, Al Worden and Michael Collins have passed away since then in the past few years. But the astronaut that we know best here in New Mexico is this gentleman in the blue bow tie here. This is Harrison Smith. He actually still lives here in Albuquerque. A outdoor planetarium was actually dedicated to his name up in Rio Rancho, and he still does several talks and presentations in New Mexico. So we're really glad that he still lives here in New Mexico with us and is able to share his experiences with us. And these are the landing sites. So this map shows you both the near and the far side of the moon. So whenever you look up at the moon at night, it may look different because the moon goes through phases. Different parts of the moon are being lit up by the sun as it goes around the Earth. But basically the same side of the moon always faces the Earth. So this side of the moon that you see on the right side of your picture, we never see that from the Earth. We only ever see this picture, this side of the moon that's on the left side of your picture. And so, of course, we wanted to land the astronauts in places that were on the near side of the moon, because then they could maintain communications with the Earth all the time. And so there you see the landing sites. All right. So I'm actually going to, well, I can't look at the chat while I'm sharing my screen. So if anybody does have any questions or comments at this point, I can still see the question and answer screen. So please type any questions or comments you have into the question and answer screen, because I can still see that. Sure. All right, yes, I can. Okay, so let's go on now that we've heard about the last time people went to the moon and talk about the next time people are going to the moon. So there is a new project going on called the Artemis Mission. And in the lower right-hand corner of your screen, if there's nothing from Zoom that's blocking it, you can see the website that you can go to and find out about the Artemis mission after this talk yourself. There's actually several interesting videos you can watch on that website. I decided not to try to play a video during this presentation, because if you've gone to any Zoom presentation where somebody's tried to play a video, you know that they don't always turn out very well, because the resolution is sometimes low and the frame rate is cut. But you can go to that website there and see any of the videos that I would have brought to you today in full HD and uncompressed and all that good stuff. So I'll let you go to that website and help yourself to those videos. But they chose the name Artemis because she, in Greek and Roman mythology, was the twin sister to Apollo. So that makes it appropriate, since this is the follow-up to the Apollo program. She was also the mythological goddess of the moon, and also hunting. So it takes a really good aim in order to hit the moon from the Earth, because it's quite a distance away and it takes about 3 days to get there. So that's another good reason for naming this program after Artemis. The ultimate goal of Artemis is to establish a permanent human presence on the south pole of the moon. And we'll talk a little bit more about that in just a minute. Okay, so just like President Kennedy started the Apollo program, Vice President Pence in 2019 made a speech where he announced that we were setting another goal to return people to the moon by the year 2024, and actually established a permanent presence by 2028. So the 2024 goal has sort of gone back and forth in the past just a couple of years. At first, they said they weren't going to be able to achieve that goal, and now they've gone back and said, by they, I mean NASA, has said that they can achieve that goal by 2024. So, you know, time will tell, but so be looking for the launch of people to the moon, or the launch of landing people on the moon sometime around 2024, but don't be too surprised if some circumstances cause them to have to push it back to 2025. So why do we want to go to the moon? Well, we want to study the process of formation of the Earth and the moon. You can actually do studies of the sun from the moon that you can't do from the Earth because of the Earth's atmosphere. You see understanding of volatile cycles. Volatiles are things that vaporize. And so like water is a volatile. So they want to understand what water does on the moon, because there is some water on the moon. There's no liquid water there as far as we know. It's all frozen. But we want to know what happens when water is exposed to a vacuum and is heated up enough. It probably just sublimates, but we want to study that a little bit more. We also, of course, want to do some fundamental lunar science research. We want to know what effect the moon has on the Earth. And it's also a platform for studying the universe because, and again, just like when I mentioned the sun, you can do some research in astronomy on the moon that you cannot do on the Earth because of the Earth's atmosphere. For example, if you set up a radio astronomy observatory on the far side of the moon, you'd be able to detect way more than you could from the Earth just because of all the radio noise that we have here on the Earth, like, broadcasts and cell phones and things like that interfere with those sorts of observations from the Earth, but on the far side of the moon, you don't have to worry about it. So here's why, or the general overview of what's going to happen between now and 2024 or 2025, whenever they actually get there. So the LRO, Lunar Reconnaissance Orbiter, is still in orbit around the moon, making observations and trying to help determine the best landing site. And we're also just beginning the process of launching several small little landers, which will set foot on the moon and do research in different areas to try to figure out what the most areas and the best areas to land people will be. You'll notice in the middle of your screen there, it says the Volatiles Investigating Polar Exploration Rover, VIPER for short. So if you hear about the VIPER rover, that is going to the moon. It's going to do some research on the South Pole of the moon. And I'll talk a little bit more about the South Pole in a little bit, but there's a lot of reasons why we want to go to the South Pole of the moon, including that is one of the places where you find frozen water. We ultimately want to have a permanent human presence on the moon and in lunar orbit also. And I will talk there in the middle of your screen, you see the Gateway. Gateway begins. Gateway is going to be a space station in orbit around the moon. And I'll talk a little bit more about that in a moment too. So the launch vehicle that's going to take people to the moon is going to be called SLS, Space Launch System. And it's quite a substantial rocket. You can see that it's going to take a lot of work. On this screen, it says it's going to take 60,000 workers. On the next screen, there's going to be another number. I'm not sure how they established either number. This one says 32,000 jobs. But basically, if you see your state on this map, there is some company in your state that has something to do with the Space Launch System. And of course, the NASA centers that you see scattered around the United States are directly involved. All the NASA centers are directly involved with the Space Launch System program. So this is how it will compare to other launch vehicles. Compared to the Statue of Liberty, and you also see right down here a little person and a little giraffe right there. So the Space Shuttle wasn't very tall. And there's going to be two different versions of the Orion, depending on what they're using it for. So there's going to be a Block 1 configuration and a Block 2 configuration. And I believe Block 2 is what they're going to use to take people to the moon. And then I mentioned the Saturn V a little while ago. You see Saturn V on the far right side there. And you'll notice the height of the rocket, that the Space Launch System is exactly 1 foot taller than the Saturn V. And I have a hard time believing that wasn't just somebody's ego making it just 1 foot taller. But anyway, it is going to be the tallest rocket that we've launched, I believe. Definitely the tallest rocket that we've used to launch people in space. And here you see different variations Like I said on the previous screen, you saw block 1 and a block 2, but there's further divided into block 1B and block 2. And depending on what mission these different rockets are serving, you can see that there's lots of different ways in which they can configure them. So they can add more. So here you see the most basic version over here on the left, and then they've added extra stages, the part with the US flag on it whenever they need to go even farther out into space. And you can see they're all different heights there too. So the tallest version is the one that's actually going to have the Orion crew module on it, and with the new launch escape system on top. And this is a further breakdown of the largest version of the Space Launch System. So again, you can see the launch abort system on the top there and the crew module. And you can see that there's lots of different stages that are stacked on top of each other to get the astronauts where they need to go. One major difference between the Saturn V rocket and the Space Launch System is the Saturn V rocket had all liquid propellants taking people into space. The Space Launch System is going to have solid rocket motors, similar to the ones that they used on the Space Shuttle. And you see them up above and down below there. Okay, so I'm going to zoom in to the top of that, and this should look a little bit familiar. You may wonder why we're waiting 52, almost 53 years now to return people to the moon. One of the reasons is because of the Space Shuttle. So back in the 1970s, there wasn't enough money in the budget for space exploration to both build the Space Shuttle and build a permanent presence on the moon. So they had to choose one or the other. So they chose the Space Shuttle because they thought they were going to build the space shuttles. They were going to be cheap and easy to operate, and then they turn back to the moon and go back a lot sooner than we ultimately are. Unfortunately, the Space Shuttle turned out to be a lot more difficult to keep flying than they imagined. They thought that they'd be able to launch a space shuttle for a few thousand, for tens or hundreds of thousands of dollars. As it turns out, each space shuttle launched cost about $1 billion, more or less, if you added absolutely everything into it. So that was a much more expensive system than they thought it was going to be. So that basically used up all the budget that would have been used to go back to the moon before now. So so the space shuttle, of course, is now retired. All the space shuttles are in museums somewhere. So that's why we're able to turn back to exploring the moon at this point. So, the space shuttle did a lot of good. We learned a whole lot about working in low Earth orbit with the space shuttle program. But now that that's been retired, that's why we're heading back to the moon at this point. But anyway, I told you that whole story just to illustrate the point that you'll notice that they're sort of turning back to the traditional design that they used in the Apollo program to return people to the moon. So you see the crew module, which looks amazing like the command modules in the Apollo program. This one's called Orion, and I'll show you the inside of it here in just a little bit. There's a new launch abort system on top of it there, a different kind of service module. This one's got solar panels on it, and then of course you have to have an adapter to launch to connect it to the Space Launch System. The Orion module is a little bit bigger inside. It's able to hold 4 people and a little bit more comfort with a little bit more room than just 3 people like the command modules did. So you'll see 2 people sort of in the foreground on the left and the right there, and then you'll see 2 people below them. You can just see their legs basically and their arms to the left and the right below the 2 in the foreground. You'll see them in the background there. And again, you see control panels with lots of buttons and switches and knobs on them, but way more sophisticated computers and touch screens and a lot more sophisticated electronics on board. So you're looking at the inside. Of course, the Orion capsule has not carried people into space yet. So this is just a trainer, and hopefully they'll clean up all the wires being held with painter's tape to the walls whenever they actually launch people into space. So this is just a simulation that they were doing. All right, so Artemis I is coming along. This is the first of 3 Artemis missions that will ultimately result in people returning to the moon's surface. So Artemis I is actually going to be happening fairly soon. It's going to be launching towards the beginning of February of next year, so just 3 months from now. It's going to have a lot of different objectives. So it's going to launch off of the Earth. You see there, it's going to circle around the Earth. And then on its way to the moon, you'll see that letter A there. It's going to launch a whole lot of little CubeSats. CubeSats are like tiny little satellites if they go in orbit around something, or tiny little spacecraft if they just kind of fly out into space. And they've got lots of different missions that they're going to embark on. And I'll show you what some of those what some of the studies are that they're going to do in a slide in just a little bit. But anyway, after launching the CubeSats, the Orion capsule will continue on. It'll actually, it's actually going to go into orbit around the moon and go into a loop that's going to carry it well beyond the moon for a little while. This is a pretty long mission. By looking at this map, you would think that it would only be, like a week or a little bit longer, but it's actually going to be a mission that's going to last about 26 days. So it'll be gone for almost a month. And again, this whole time it will be launching CubeSats along the way and making sure that the Space Launch System can reach the moon safely and then return back to the Earth safely as well. So here's where the CubeSats are going to go. One is going to go do some studies around the sun. There's several that are going to go into orbit around the moon, and one is going to go into a huge orbit around both the Earth and the moon system. There's one that's actually going to go to an asteroid, and a few others that are just going to kind of fly out into space or go into other orbits. So they're really making the by they, again, I'm talking about NASA, is really making the most out of this launch. So not only is it testing the whole Space Launch System and the Orion capsule, but it's also doing some space science with all these CubeSats being launched. So this is going to be there's not going to be a crew on this mission, not going to be a living crew, but there is going to be one occupant in the Orion capsule during this time. And so this is basically a mannequin that they're calling the Moonikin because he's going to the moon. And NASA had a contest to name the Moonikin a few months ago. And there were several different names that were proposed, but the ultimately winning name was Campos. So he's going to be named Moonikin Campos, and he's named in honor of Arturo Campos, who was a safety engineer back during the Apollo missions. In fact, he was a key player in bringing the Apollo 13 astronauts back to the Earth safely. So this mannequin is being named in his honor. So you'll see that the Moonikin is going to have the same spacesuit on that the astronauts will ultimately wear. And so they want to make sure that this spacesuit will protect the astronauts from radiation and any other stresses or hazards that they may face in space. So this is a test of that spacesuit, basically. And it'll be a nice long test since the whole mission is going to be 26 days long. All right, then there's going to be Artemis II. So there will actually be living people on Artemis II, but these people will not be actually landing on the moon. They're just going to blast off from the Earth and do an orbit, do a circle around the moon, and then return back to the Earth. So this will be the first test of people actually going to the moon and returning to the Earth. And this will be similar to some of the early Apollo missions that were done before the first moon landing for Apollo 11. Then we have Artemis #3. And this will be the mission that will actually return people to the surface of the moon. So you can see them blasting off from the Earth there. And then you see something called the Gateway Orbit. I'm going to talk about the Gateway Space Station in just a little bit. But that is a space station, which I understand from a recent talk that I saw is actually being constructed right now. So it's really going to happen. And it's going to go into orbit around the moon. And it's going to be the platform that is used to transfer people from the Orion space capsule to the craft that's actually going to land on the surface of the moon. So what kind of space vehicle are we going to use to land on the surface of the moon? Well, It's going to be one of these three, and it's most likely going to be the one in the middle. So these were the this mission to the moon is actually going to be a joint effort between NASA and private industry. So they decided that the part of the mission that they were going to leave up to a private contractor was going to be the actual the craft that actually landed on the surface of the moon. So they had three proposals. The one on the left there that looks kind of like a giant space rabbit is a lander from a company called Dynetics, which is based in Alabama. The middle one there is from SpaceX, and you know SpaceX has been launching a lot of rockets and doing a lot of work in space recently. And then the one on the right there is from Blue Origin, which just recently is the spacecraft that took William Shatner into space. So there was a competition between these three proposals. The SpaceX one there in the middle was the one that was actually chosen by NASA. Well, the other two companies, Dynetics and Blue Origin, pointed out that SpaceX had actually been chosen for another part of the Artemis mission as well. They didn't think that when the U.S. government chooses contractors, they're supposed to look at lots of different contractors and not just one. So Dynetics and Blue Origin actually got together and filed a complaint with the U.S. Government Accountability Office and said that they didn't think that the selection process was fair. Well, back in July, the Accountability Office dismissed the complaint, basically. And so then Blue Origin filed a lawsuit in federal court. Well, just a few days ago, that lawsuit was denied, basically. The lawsuit was canceled from Blue Origin. So now that the complaints and the legal challenges are out of the way, I'm a little more confident with saying that that concept in the middle, this Spaceship One concept from SpaceX, is what is actually going to land people on the moon in the future. SpaceX has actually been doing a lot of research with Spaceship One, and it's actually got some capabilities that the other two don't have. So that might have been part of the reason why it was chosen. But they are actually want to use that in the future to maybe land on Mars and do some other missions as well. But anyway, so you're probably going to see something like what you see in the middle of your screen there, actually landing on the surface. And then that spacecraft will actually take off from the surface of the moon again, rendezvous in some way with the Orion capsule, and the Orion capsule will return to the Earth and be recovered in the water, similar to what the Apollo command modules did back in the 1960s and 70s. So who is going to the moon next? Well, this is the list of astronauts that will be participating in the Artemis program. There's 18 of them here on the screen, and I don't know which ones will be involved in which missions. I'm not even sure that they know at this point which ones will be going on which mission, so I can't tell you who will be the next person to set foot on the moon, but it'll be one of these people that you see on your screen right here. So there's a much bigger collection of people in this initial astronaut group than they had for the Apollo program. And so, they'll cycle through these people basically and send them on different missions so everybody has a chance to return to the moon at some point. But take a good look at these faces, because you'll be seeing them a lot more in the future. And once again, I don't know which one it's going to be, but one of these people is actually going to be returning us and setting the first footprint on the moon in what will that be, 56 or 7 years at that point, whenever we actually get back there, after the last person set foot on the moon. And the last person off the surface of the moon was, well, actually, I'm sorry, the second to the last person off the surface of the moon was Harrison Smith, that lives here in Mexico. So it'll be a good long time before, it's been a good long time since anybody's actually done any walking on the moon. If you don't, so there's only 18 people that are looking at that opportunity. So if you don't get a chance to go to the moon as an astronaut, there are lots of different ways in which you can participate in going into space in the future if you're interested. You can see that NASA every so often actually has competitions to let people be social media reporters for different space missions. So you can go to NASA's website and find out more about those. There was a graphic designer who put all of these slides together that I'm showing you today. There's robotics engineers that are going to be building the next version of the moon buggy that you saw that was used in the Apollo program. First, you have to have spacesuit designers that the astronauts wear to keep them safe. You have to have trainers for the astronauts. NASA actually accepts interns, so you could apply to be an intern at NASA. And then there's lots of mechanics that are needed. So if you want to be a launch pad construction worker and carry a giant wrench around on your shoulder, like that guy in the lower right corner, that's an opportunity that you can pursue. You can also be a flight controller and work in mission control and talk to the astronauts all the time. So there's lots and lots. There's literally thousands of different professions that you could pursue that will let you be part of the Artemis program. Okay, I mentioned earlier the Gateway Station. So as I said from a recent talk that I went to, I understand that parts of the Gateway Station are actually being constructed at this point. This is a space station that will be in orbit around the moon. It's going to be the transfer point for the Orion capsule docking, and 2 astronauts will stay on board the Gateway Station while 2 others go down to the surface of the moon. Let's talk a little bit about the parts of the Gateway Station. So there's this part called the propulsion and power module, and it's you can see that there's a couple of contractors, private contractors, that have gotten the award to construct that part of the space station. And then this is the logistics services module. This is the other part of the program that was awarded to SpaceX that I mentioned a little while ago. This is basically going to be the delivery truck to the Gateway Space Station. So this is going to deliver supplies to it and then basically haul the trash away whenever everything that's been delivered to the space station has been unloaded. This will take the things that aren't needed on the space station anymore away. And so here's sort of an overview of what we think the Gateway Station is going to look like. So over here on the right-hand side, you see the Orion module. This is maybe something that's going to happen in the future with some international partners. You can see there's a lot of different international partners for this endeavor. So NASA is obviously one of them. The Canadian Space Agency is involved, European Space Agency, Japan, and believe it or not, even Russia, even though we were in a space race with Russia when we went to the moon with the Apollo program, they're actually participating with us on this space station. Down here at the bottom of the photograph is sort of a generic drawing of what they thought that a lander to the surface of the moon might look like. Of course, if SpaceX gets to provide that service, then it'll be something that looks significantly different. Here is SpaceX's logistics module. So that's where all the supplies will be coming in. And then that power module that I showed you a couple of slides ago is back over here with the solar panels attached to it. So here again is another timeline with the Gateway Space Station drawn in. And you see this lunar terrain vehicle. That's going to be sort of a new version of the moon buggy that's going to be letting astronauts drive around on the moon. There's going to be some other little rovers and landers, but ultimately what we want to do is have a permanent habitat on the surface of the moon that will grow over time. If any of you have watched the show For All Mankind, it's on, I'm not endorsing any network or anything, but it's on Apple Plus right now. I think you can probably get it in other places, but they're the ones that produced it. But basically, it's an alternate timeline. And the premise of the show is that the United States did not get to the moon first. The Soviet Union got to the moon first. So this is a fictional alternate timeline. And in that scenario, the space race basically never ended. So Russia and the United States were pushing each other in this fictional show. And they both had space stations on the moon, or both had moon bases on the moon by the 1980s. So it's kind of an interesting thing to watch of what might have been if history had unfolded a little bit differently. But we're going to make that fiction into reality soon. by actually having people on the surface of the moon permanently. And going back up here to the Gateway Station, you can see that it's, like the International Space Station, you can sort of tack little bits and pieces onto it over time. And over on the far right side, you see that there's a habitat that they want to ultimately put on it at one point. So remember at the beginning of my talk, I mentioned that we want to ultimately we want to send people to Mars, and you see Mars in the upper right-hand corner there. So in order to sort of figure out if people can survive in space for the duration of time that it would take to get to Mars, they want to put this habitat on the Gateway Station and let people stay there for several months and see if they're able to, survive in that environment. We want to do this sort of test in, relatively close to the Earth. So if something does go wrong, we can get the astronauts back to the Earth fairly quickly. But it's hard to do this sort of a test. Well, you really can't do it on the surface of the Earth, and it's hard to do it in the Earth's orbit because the Earth's magnetic field actually blocks radiation from the sun. But if you go out to the moon's orbit, that radiation shield isn't there anymore. So you get a much more realistic test of what it would be like to fly all the way to Mars. So that's why they want to do tests like that in the future. So you may have noticed in that graphic for Artemis III that the Gateway Station has kind of an unusual orbit. It's called a near rectilinear halo orbit. It's also called a cislunar orbit. So let me break all that down for you. You may, if something's going into orbit around something, you think of it making a big circle around it, but this Gateway Station is going to be in this highly elongated elliptical orbit. The reason they want to do it that way is because it's a whole lot easier for the Orion capsule to dock with the space station when it's far away from the moon, because they don't have to compete with the moon's gravity basically while they're docking. And then the space station goes into a really low orbit around the moon, and then it makes it a whole lot easier for the SpaceX lander or whatever kind of a lander they end up with to actually get from the space station down to the surface of the moon. It takes a whole lot less energy that way, a whole lot less time too. And then, when they're ready to leave the moon, they jump back, when the space station it's in its low orbit again, and then the space station swings back out, goes to the orbit that's far away, and that's when the Orion capsule leaves and goes back to the Earth. So these are the different kinds of orbits they considered, but they like this halo orbit the best. And the cislunar part of the orbit means that it's going to be in an orbit that's slightly inclined, so it's not going to go around the equator of the moon. It's going to when it's going behind the moon, it's basically going to go up above the moon as well, so that the space station will actually be directly in line of sight at the Earth at all time, and will be able to maintain radio communications with the Earth at all times. And here's some different sort of infrastructure that they want to put on the surface of the moon. So you got to have electrical power up there. So this thing in the middle of your picture is actually a small little fission nuclear generator. I believe this thing up on top of it may be some solar power to control the components inside the generator. So that's how we think that they're going to get power on the moon. So you don't want to go anywhere without the internet, right? So they're going to have LunaNet. LunaNet is going to be the moon's own little information network, and it'll actually connect with the Earth through the Gateway Space Station. So there's going to be some tiny little satellites they're going to put up all the way around the moon. So no matter where astronauts go on the moon, they'll always be able to communicate back to the Earth easily through this network, and also be able to get data and know where they are and know if there's a solar storm happening or whatever the case may be. So LunaNet's coming. And they also, initially they want to have a little moon buggy, but they also want to have this crewed vehicle. It's kind of like an RV on the moon, kind of like a recreational vehicle on the moon. And they'll be able to jump into that and actually do missions away from the base station for maybe up to 90 days. And so you'll be able to drive around the moon and live in some comfort and be able to survive much farther excursions on the moon in the future with that. So here's another reason for going to the moon. There's a lot of minerals on the moon. I heard somebody do a talk the other day where they said that one of the main goals for going out into space is we want to do all of our industrial processes on other objects and basically rezone the Earth as residential. So I like the whole idea of rezoning the Earth as residential. So you see some of the those different colors that you see there represent different resources that we might want to excavate on the moon someday. And I was a little confused when I saw this picture at first. I didn't realize that they flipped the moon upside down from the way you normally see it in the sky. But the reason we want to go to the South Pole specifically, one of the main reasons, is that the Lunar Reconnaissance Orbiter, which I mentioned a while back in my talk, has actually detected the presence of some water ice on the South Pole of the moon. And here, the blue shaded areas are the areas where LRO has detected higher concentrations of water. So if you land someplace, or if you put a moon base someplace where there's already water, not only will you have water to drink, you can actually separate that water out, and you can use it for oxygen inside of your habitat, and you can also use the hydrogen for rocket fuel. So water has lots of different uses out in space, so we're always looking for water whenever we go out into space to use it as a resource in the future. If you look at the sort of the middle of this picture, we're going to zoom in on the middle of this picture. And there's that crater, and the crater right there in the middle is a Shackleton Crater, and this graphic was produced by NASA in Washington, so they overlaid the highway system in Washington over the top of it, just to give you some idea of how big it is. It's a pretty big area there. And so the initial idea is to put the this moon habitat somewhere around the rim of Shackleton Crater. If you're on the South Pole of the moon, you also get you get a long duration of darkness and a long duration of daylight, because it's just like being on the South Pole of the Earth. So if you want to do some of these observations that I mentioned earlier without the radio noise and all kinds of things coming from the Earth, you could do that when it's whatever side of the moon, whatever the side of the crater that you're on swings in around to the dark side of the moon. Or the far side of the moon, and then you're able to do those. So there's it makes a lot of sense to put your first base down there by the South Pole. Also, you can probably, even without the gateway station, stay in radio communications with the Earth all the time that way too. And here's a concept drawing of what it might look like of astronauts working on the surface of the moon. They're doing some geological research. It looks like they're in the lower part of the picture there, and they're getting ready to go into their moon recreational vehicle. In the middle there, you see one concept for a habitat in the upper right corner. Hopefully we'll be able to add on to these concepts in the future and have lots of even bigger and bigger and bigger moon bases eventually. And then you see the new version of the moon buggy over there on the right side. Okay, so let's talk a little bit about going even farther out in space. So if you want to just go into low Earth orbit, it takes about 3 hours. The reentry temperature is about 3,000 degrees that you have to endure to slow your spacecraft down from that 17,500 miles per hour that's required to stay into orbit, escape Earth's gravity. And it can go anywhere from about 250 miles up. If you want to go to the moon, then that takes about 3 days. You have even higher temperatures that you have to endure during reentry in order to slow your spacecraft down from that speed that you see there. And it's a much longer trip as well. But neither of those has a lot of comparison to going to Mars. So a Mars mission would be at least 9 months long, because it takes a few months. Well, it takes about 7 or so months. Actually, that just to get to Mars takes about 7 or so months. Then you have to make a choice. You can either spend 2 months there, or you can spend 2 years there. So initially, we're probably going to just spend the 2 months, and then it'll be another 7 or so months coming back. You have to endure even higher temperatures during reentry to slow down from that speed. And of course, it's a whole lot farther. So here's a concept drawing of what it might look like for astronauts to be on the surface of Mars. And this is something that hopefully will become a reality sometime in the 2030s, probably towards the end of the 2030s. But the whole mission to the moon is basically to build up our knowledge base and test our technology and develop resources in order to be able to get to Mars at some point before too long. And so all this going to the moon, it has benefits in and of itself, but it's also just a preparation for us actually visiting another planet with people someday in the not too distant future. And if people do get to stand on the surface of Mars and look back at the Earth in the future, this is what they might see. So just like we see Mars as a little dot in the sky of the Earth, occasionally, this is what the Earth would look like this is what the Earth looks like in the sky of Mars. This was actually a picture taken by the Curiosity rover, I believe. And so that arrow there, is that little dot that you see there, that actually is a picture of the Earth from the surface of Mars, taken by one of the rovers that we have there. So hopefully we'll be able to make that a reality someday in the next couple of decades or so. I'm going to stop sharing my screen. Got a couple of things for show and tell. My face mask that I brought with me today, which just disappeared, actually has drawings on it of calculations that were done to go into orbit around the moon. A lot of these calculations were done. You remember we had very, very simple primitive computers back in the 1960s. So a lot of these calculations were actually done by people. And one of those people was Katherine Johnson, who actually passed away at 102 years old just last year or 2 years ago. And she was a trailblazer in figuring out what kind of math was needed in order to escape Earth's gravity and go into orbit around the moon. So those are some of her calculations. And I've mentioned Harrison Smith a couple of times, and I've actually, on my lanyard that I wear around the museum, I've actually got a little pin that he gave me one time during one of his talks. So you see, I don't know if you can see on the top there, it says Harrison Smith, Apollo 17, there on the top. So if anybody, let's see, we've got about 10 people watching, it looks like. So at this point, if anybody would like to ask a question, please type your question into the chat or the Q&A, and hopefully either of them will work equally well, and I'll be happy to try to answer them for you as best I can. But otherwise, if nobody has any questions, I'll just bring an end to our presentation. So I'll wait just a couple minutes to see if anybody does have any questions. Oh, here's one. Hold on a minute, I have to move the, oops. Doing this by myself, so I have to move the chat window, the Q&A window out of the way. Will it be like the Apollo missions? So there are some ways in which the Artemis mission will be like the Apollo missions. They're going in similar capsules that are a little bit bigger and a lot more sophisticated. They are going to have some way to get to the surface of the moon, and then they're going to re-enter in a very similar way that the Apollo capsules did. They're going to be different in so far as I think each mission is going to be a little bit longer. The first one might only be a couple of days like the Apollo missions are, but they're actually taking more technology and infrastructure along to be able to stay on the surface of the moon longer until we can build up to the point that we can have a permanent presence on the moon. So this mission will be a little different in that we actually have a long-term goal to stay on the moon, not just go there for very short visits. So that's one of the ways in which it'll be different, but there's a lot of ways in which it's the same too, as you saw from the very similar spacecraft and at least the Apollo, the command modules and the Apollo crew modules are very similar. Are there any special considerations for dealing with moon dust? Yes, I've seen some concepts of ways in which they might actually leave their spacesuits on the outside of the that RV that I showed you, that moon RV. I saw one concept of it where the spacesuits were actually left on the outside, and the astronauts had to climb into the spacesuits through kind of a little airlock, and then they detach and walk around on the moon. That way, you're not dragging that moon dust into your moon RV with you, and you don't have to, because you can imagine if they took that that habitat with them and they went out and explored different parts of the moon every day and dragged all that dust back in, by the time they were done after 90 days, it would get really, really dirty inside. So they might actually just leave the spacesuits outside, and then that way they could leave the dust outside too. Of course, if you're probably going to get some moon dust at some point, and they will clean it up as best they can and probably bring it back to the Earth, bring as much of it back to the Earth as they can, because they actually study moon dust whenever the Apollo astronauts went to the moon, not only did they bring back moon rocks, but every little bit of moon dust that they brought back with them was actually captured and is stored down there at the Lunar Research Office in Houston. So I'm sure there are going to be some special considerations for moon dust. Any other questions? Okay. Well, if nobody has any other questions, I'm going to thank you all for participating in this program today. Remember, there's going to be another live program at 5 o'clock today, done by Aziz Gonzalez from the Santa Fe Children's Museum. The link is on the Cosmic Carnival page, and you can also please enjoy all of the other videos that you can watch on the Cosmic Carnival page. And hopefully we'll be able to see you all in person next year. But until then, thank you very much for joining, and please stay tuned to what's happening in space. We're glad that you're interested in what's going on in space, and hopefully you'll, when in a few years when we reach the moon, you'll know exactly what's happening, and you can share that information with other people. So thanks very much and have a good day.